All right, so let's continue our second part of this lecture on intelligent agents. And so we saw there's different environments or agents can operate in, right? So let's look at this idea of fully observable environment, right? And partially observable, right? This won't work, right? This won't work because I don't see that. So in a fully observable environment, the agent, your bot, knows everything, right? You can observe all the information, right? Complete state, right? Knows what cards are there, right? What are the situations you're doing it, driving robot, yeah, it's a closed room, you know everything about the environment, right? In a chess game, right? Chess game is fully observable because you know where each piece is, right? But there is actually like playing poker, right? Which is not fully solved yet, by the way, right? Problem, you don't know some information. You know what your opponent has, right? It's hidden from you, right? You can make some good guesses, but it's still hidden information, right? So it's one of those things. Again, you have to decide what kind of environment you're going to be operating in. So obviously, again, going back to our self-driving car, it's going to be partially observable, right? Because you know the traffic cones and those things, right? You're not going to see them, right? So now, so deterministic versus stochastic. We talked about this again. So your next state, your move you make, you move to the next state. Deterministically, you know exactly where you're going to end up, right? So production line, this is example of the production line, right? You put the wheels, right? It moves to the next stage, right? It does not go jump into space or it does not fly in somewhere underneath, right? It keeps moving, right? It's deterministic again. Well, there's some leader, right? It could be unknowns, right? It could be production line stoppage, things like that. But in general, right? You're building this agent, right? And again, here you have a different level of agent, by the way, right? You have a whole production. You could think of this whole factory as a one big agent, right? Of course, you have sub agents here for each section, for example, here, right? But it is deterministic, right? So, again, driving in real life situations, you don't know where you're going to end up. You start driving to Tukums, right? You end up, I don't know, in Uagre, right? I don't know. But basically, well, you have small, right? Things will happen, basically, right? So, now, what else we have? So, by the way, so human, yeah, this is what I was mentioning, right? So, the human element, you have agents, right? Working, and you have deterministic, next move, where should end up. But the human element can end up changing situation, right? A human in the loop, right? Does something unpredictable, right? And here's the situation, right? Robert Williams, he's this poor guy, he was the first fatality, first casualty in a human robot wars, basically, right? So, probably not the last, right? So, but no, seriously, unfortunately, he was, there's also really cool, well, I think a really cool video by Chemical Brothers, the lead, right? And it's probably inspired by this, right? Or the production factory, right? So, we're going to have to link to this today, not yet. So, right. So, again, if you're building some sort of intelligent agent, you have to also take into account because there's going to be some human interaction, right? Then it's almost automatically it's going to be undeterministic, basically, right? So again, multiple things you can consider also, right? Episodic, right? The environment, right? Factory robot does something like really simple, like replace, put a wheel on, or like maybe soldier something. Does one thing, right? Each decision is isolated, right? A sequential environment, each thing you do affects the next thing, so it keeps building up, right? Each move you make doesn't mean something for the future, right? So we talk about static versus dynamic, right? Static environment doesn't change. Dynamic environment, Like let's say if you're building a bot for a first-person game or a real-time strategy game, who here plays real-time strategy games? Okay, which one? Okay, yeah, all right, yeah. So, but again, if you're building a bot to play this game, I don't know if it has an API call, it doesn't do something, right? I'm building a StarCraft, StarCraft 2 bots, for example, right? It is like if your bot does nothing, right? In a static environment, that's fine, right? If you're doing a puzzle solver, right? Or a solitaire, right? Nobody, you have bot for solitaire, right? Nothing bad's gonna happen if you don't do anything. But if you're dealing with like first-person shooters or real-time strategy, right? If your bot does nothing, it's probably gonna get killed, right? It's gonna lose, right? Because things will happen, right? Dynamic, right? Things will happen, right? So things is continuous, right? So discrete means you have a set number of positions, like in a solitaire, right? The board. Let me load the board. I don't know if I have solitaire here. I probably do. Let's go. Yeah. Come on. Going back to my old friend. All right. That's probably going to send a whole bunch of tracking information about my interests. But, all right, so we do classic solitaire. I know people have complained about this approach. Why does it need to sign in? That's not really what solitaire is all about. All right, solitaire is. Why do I want to save data in the cloud and for solitaire? I mean, yeah, I know. I mean, yes, I know the rules. Okay. Yeah. Oh, okay. All right. So, why do I want to show this? Because, so you have discrete moves, right? I mean, if you want to build a bot, you could store like in a floating point, you could store the coordinates, right? For each move. That can be silly, right? You don't really need that. You have discrete information like maybe some, I don't know, some simple two-dimensional array maybe, or some structure. What kind, like you have a card deck that's open, you have some structures here, right? On also like 6 or 7, arrays or whatever structure you want to use to store what's open, right? So maybe how many cards? Probably what, 54? No, 52? 52, right? No jokers, right? 52 cards probably, right? So 52 cards. So positions certainly is discrete, right? So continuous environment, again, going back to the car, it's going to be basically, potentially limited, right? Basically floats. Whenever you have floats, that means you have a continuous state, right? Discrete mass, 0, 1, 2, 3, 4, 5, right? Floats, you have continuous range of values. So which one is simpler to deal with? Discrete, right? Because, okay. All right. So, again, you have challenges here, of course, so different type of environments, will call for different type of agents, right? So, let's control it. So, there goes sorting robot. I wouldn't say it's a solved problem, but it's extremely much easier to solve than a self-driving car problem. Right here, right? And there's the Waymo taxis here. Maybe I'll upload. So okay. So we're going to be building some agents in this course again, and I had a colleague asking for more homework. There will be an option to do more homework, right? So I know not everyone wants to do homework, but some of you want it, which is fine, right? Maybe do some again, assuming you have different schedules, right? You want to practice more, so there will be possibility to do more homework, right? So if you're going to build a homework, you're going to build an agent, right? So sensors, right? You need something, basic inputs, right? Inputs, as classically we understand, right? Actuators, right? So that's of course, if you're building a self-driving car, you need a lot of actuators, right? You need maybe at least gas, actually for gas, brakes, wheels, right? At least, for turning, right? What else do you need? Lights, right? What else do you need? Yes, windshield wipers probably too, right? I suppose, right? All right. So, but how many have driven a car with adaptive cruise control? Anyone? Yeah. Pretty cool thing, I think, actually. Right. I'm a big fan. Right. So it's an agent, right? It's not again. It's not. Of course, it has a limited set of functionality, right? But it has the goal, right? It has a. It's in a very similar terms, right? It has a distance, right? There's different levels of how smart they are, different cars, different levels. But the idea, at least, is it measures the distance, has some sort of sensors to the next car. It tries to determine whether there's a car or not, right? Personally, I mean, luckily, I have not had a problem this time. I always imagine how does it determine that there's incoming car, right? Like, if you, especially on turns, right? If you're driving it, right? And there's a car coming from another direction, but for a split moment, it could appear to be right in front of it, right? So there is some way of determining that the car is oncoming, right? It's not in your lane, right? So I don't know. This would be also a very good topic to discuss in more detail, actually, right? How these simple adaptive cruise control, right?
Probably it's determined by the position of station.
Well, you mean of which car? Of the car which is you are driving, right? Okay, you're driving. Okay, but I mean this. Maybe I should. I guess you're driving a straight line. Okay, I'll do paint here. My favorite, right? Come on, paint. All right. So, what I mean this is going to be a road. All right. All right. And this is going to be the middle lane, right? This is the middle, right? And we are going to be the red car, right? This is you. And the idea is this is like the green car is coming at us, right? Here, right? Right? So, I'm saying, how do you deal with the idea that at the moment it can appear right in front of you, right? Right. So there must be something that determines that this is not a danger, right? Because instinctively, I think too much about this, right? When I'm driving using this, right? What happens if there is some sort of, it thinks it's a collision, it tries to brake. That's what I'm afraid of, actually. That's what I'm scared of. Because as you know, I've told you that this example case is this problem, right? When on a freeway, right? There's no exit, it decides to stop, right? Right? You thought there was a shortcut to the left side, there's no exit, basically. It had bad information mapping. Right? It says stop and there's 9 cars behind it, right? So it kind of scares me because this is a simpler agent, right? But it works so far, so good, right? So there must be something that determines that this car is actually there's some sort of lane control, but in Latvian roads, you don't have the lane, so it's not painted, it's snowy, right? You might not see the middle lane, right? Right? You might not see these markers, right? So there must be something that says, okay, this car is moving. It's probably, but I'm imagining that there's multiple, it takes measurement, sensors, perceptions happens multiple times a second. It determines the car is moving, but actually determines the vector where it's going, probably. That's what I'm imagining, right? There must be some math happening, I hope, right? Right. But sometimes it could be something very some easier, solution. But also, what I wonder, what's going to happen? Again, frankly, has not happened to me. What happens if this car decides, what happens if it goes here, right? Head-on collision is happening. What's going to happen with adaptive cruise control, right? If you're driving on a on a free or regular highway, right? When the cars are going in the same direction, it works great, right? It stops, right? The traffic jams, right? It keeps going, right? Very good, right? But if there's this type of situation, what can it do? It's probably going to stop, right? But ordinarily, right, again, how is it determined that this is not a danger, right? So at what moment is it's going to, engage this brake? Right? I don't know, because thankfully I have not had a chance to test it, right, in real life situation. So none of you had this problem, sudden braking yet. Adaptive cruise control, right? You have not had any problems braking. Yeah.
Sometimes when I would maybe continue at the same speed for some time.
Yeah.
It wasn't very big.
Because I've tested different cars, right? My newer car has one, and I had some rented cars which had this too, and they work a little bit differently. I've had some, I wouldn't say fails, but it sometimes breaks too quickly, right? And sometimes it breaks, I would say, kind of late, right? And of course, it like also, of course, the sensors are very sensitive, right? If you like drive from like a cottage where there's grass, right? Grass will trigger the straw stop. These things you're driving into a wall, right? It's actually right. There's also this is kind of related. There's this extra safety precaution. Like even if you don't have adaptive cruise control, many cars, newer cars have brake sort of stoppage also activate. It stops if you go driving into something, right? So okay, but yeah. So how this is a problem, right? Apparently, it's pretty well solved problem, right? Because again, adaptive cruise control is, I think, pretty standard now. Again, it changed your life, and it also saves you money. You don't get speeding tickets anymore, right? Yeah. So you can set, okay, 96, right? You're diving those big, boring, radar-controlled sections, right? You set like 94, right? Okay, you're going to be safe, right? Hopefully. Has anyone got a ticket on those controlled roads, meaning the timed ones? I'm just wondering what the limit is. But maybe you want to experiment, like drive 90, then 91, 82, 93, and see when you get ticket. Yeah, that's my experience too, right? But I have not tested, if I hit 96, it usually goes below a little bit, right? And of course, there's another factor that the 96 in your car is not the real 96. It's usually less because the wheels, right? Usually you can check you're driving a little bit less, right? So
97 should be fine. 98.
98 probably. So who wants to volunteer to test 98? No one.
The radar is usually like plus minus 3 or something.
Yeah.
And the limit is like 94.
Yeah.
So 97 minus 3.
Yeah. 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 But of course, they usually have plus minus 5 is like officially like, error, right? So again, okay. So we are back into agent structure, right? So reflex agents, right? Something comes in, you immediately do something. So, for example, spam filter, right? Perception is, the email itself, right? And you respond, right? Spam or not. It's also called a classifier, right? The machine learning, which is AI, right? It's called a classifier, right? Hot dog or not, spam or not, right? Right. It maintains a model-based reflex agents, right? A smart thermostat, right? What's the difference, right? Meaning not something you have it means you have some sort of state. You keep a state of the world, meaning what time of day it is, you have some data inside in the model, right? For example, a spam filter, right? If email comes in, right? You say spam or not, and you technically, right? You don't have to have worry about this anymore. You said it's a spam, you did your work, and you're done, right? But here, if you're doing something like a smart thermostat, like smart home, right? You want to keep track of the time of day. If you're away, for example, during daytime, you're at school studying, right? You probably turn off the phone, I don't know, you turn off the heat, right? You can set the signature, right? What kind of temperature you want, right? So obviously there should be some memory, right? Some state. So state and memory, that's the same thing, right? At least talking about the same thing. So a goal. So again, goal-based agents, right? You have some bigger goal, right? Navigation system, right? Navigate specific destination, right? And again, utility-based agents, you have some function, right? So here, for example, training bot, right? Exam, would be you have some utility here would be a function. Again, how much profit you made. If there's a profit function, okay. Again, that's utility. Some usage basically, right? So, and then learning agents, right? You have something happening, right? And you learn, right? This is one of the big things, right? Meaning you have some previous experience, something happened before, and hopefully your next game, next actions, well, hopefully will be better, right? Then you probably heard of like a chess or like a chess playing programs or maybe anything, right? It's something called reinforcement learning. You play over the same scenario or similar scenarios, and eventually your bot, your agent learns, improves, right? So again, not all agents are learning agents, but again, this is very, very, or should say, complete, not obviously very developing field, this learning agents. Now, also, for example, those agents structure influence interaction with the environment, right? So, reflex agents, we have a factory, simple agents, you keep it simple. Again, there's no need to complicate. One of those things is some people who write bachelor's here, most write something to do with AI, right? Some of you will be doing bachelor's thesis, right? Sometimes you have to ask yourself a question, whether simple, like a really simple strategy would be better than your really smart AI strategy, right? You're building a weather prediction bot, right? You should consider whether it actually can you beat the simple next day strategy, right? So whether you need AI, right? Whether you need some sort of something really complex, right? So now learning agents, right? Navigating traffic, yeah, but again, so this particular, like learning traffic, by the way, right? Waymo in San Francisco and Los Angeles, obviously they spend a lot of time doing this learning. They spend a lot of time driving around. And one thing I learned is, I also learned a little bit, right? So, is that they're not allowed on freeways, for example. There's some certain places where they're not allowed to go, actually, right? They're limited to certain areas, like in San Francisco and Los Angeles, they can't go between San Francisco and Los Angeles, right? You can't take a taxi, a driverless taxi yet, right? So they have some regulations in place for this, right? So there's unpredictability, right? So now, so obviously for something like this, some complex environments, you want to start dealing with learning agents, right? Presumably, you could, of course, take something which you already have some knowledge, right? You don't have something ground zero, right? These days, you're building some models, some complex models, you usually start with some knowledge already. Some they already did some training, some learning before for you. Okay, now, this is actually going to be so we're going to finish there. No, we're going to do something more. Let's see. So, we have the types of agents, a simple reflex, stimulus response, right? Model-based reflex. So there is some sort of algorithm, there's some rules inside. Goal-based, utility-based learning agents, right? So good behavior, right? So again, in AI, we have this idea of rationality, right? We make the decision. Obviously, if you're building a boat, you could add some, I wouldn't say evilness, but you could add some sub-optimal, you can make your agent irrational if you want, right? But again, most of this course in general, you don't talk about it because it's kind of useless, right? So, again, so rationality is best decision based on available information. So again, doesn't have to be imperfection, right? Not every problem will have a perfect solution, right? You don't have, in real life, you don't have the perfect solution, right? So, we need to measure this performance, right? We don't know how well we are doing, right? And again, we have different ways of measuring, right? You can't really build something, you can't improve, right? You can't really do, we say, okay, this is okay, so measurement, we need some sort of metrics how we're doing it, right? It could be days without accidents, right? Days without human skill. That would be pretty good metric, right? Yes. So, and again, it's all here again. Still not going too much into the details of different equations, right? But it depends, of course. The answer is usually it depends. It depends, right? So we have fully partially observable, split versus static, episodic versus threshold, split versus dynamic, split versus continuous. Now, are we pretty clear on these, all of these concepts so far? So far, pretty easy, right? Yeah, until we have to build ourselves. For goal. Yeah. Okay, I think I have the code here. I think I have this. Yeah, I have a very simple. Yeah. Oh yeah, let's make it. We have some. That's what. Yeah. Let's do a little cleaning agent. Really simple one. Right. This is from the. By the way, I made the agent from the book, the scenario, and I built the agent for it. Right. So you all know Python, and there's only two states: on tile, right, off tile, and two actions: suck or move, right? So vacuum, right, or move, right? And again, to keep things simple, right? KISS principle. Okay, keep it simple, something, right? So, and you can sense it, right? And you can also sense where you're going to, right? So we're gonna make a Roomba, really stupid Roomba, right? So come on, okay, I want to go back, and we can see basically here, right? So okay, and of course this mostly I'm gonna call this state, right? Name and right. So location, model, color. Some of these things are not important at the moment, right? Like weight and model or color are not important. But we're going to giving it environment, right? My name, and okay, we want to do a cleaning, right? Right. So for our cleaner, if our environment location, right, is dirty, right? We have a sensor. This is our sensor. We check the array, right? A ridiculously simple idea, right? We have data, right? Source. We check if it's dirty, right? We make it clean, right? What do we? Okay, so this is our model. This is our model for AI, right? The room is already clean, right? And then we have movement, right? Also, the question is now we have clean, we have move, right? So, and we only have two slots, right or left. We have direction, and if you can keep moving, it's a one-dimensional, right? Let me do my paint here again. New. I guess not save. Right. So I think, right. This is my little Roomba. Let me call this. I don't know. Roomba. Right. I don't know how to draw a vacuum cleaner. I don't know. I guess this is going to be Roomba. This is Roomba. Does this look like a room or no? I'll just stop.
Well, it could be better.
What are you suggesting?
I don't know. Like I'm not suggesting I can't do it.
Okay, Roomba. All right. I'm using the old trick of of writing things down to to make explain. It's not a hat. It looks like a sailor hat or something. I don't know. But okay, it works. Come on. I don't want this. Right. Okay. Right. So we have a state. We have only two. So, maybe this is dirt here. I'll do some dirt here. Right. And I paint some dirt. Let's paint some dirt. Oh, come on, I want some home. Oh, there's some dirt. Yeah, this is dirt. Dirt. I can't type. I can't write with a touchpad. But yeah, so again, two possible actions: movement or vacuuming. Right, sucking. Right. So so that very simple agent, right? But still, encoding this movement against such simple, you might say, okay, is this a rational agent, right? You say, okay, is this machine learning? No, it's not machine learning, but technically, this is still AI, right? You're building an agent, a very simple rules-based agent. So usually, when you have rules-based agents, they're not machine learning. They are AI, right? But not machine learning because they're not learning, right? You have rules. You made your rules for it, right? So let's make a. Oh, yeah. So let's make a robot. Let's make it run. Yeah, it's mine. Let's initialize this, right? So I'm going to supply extremely dirty piece of road, right? How many spaces? Like 10 places of road, right? All dirty. So I move left. I can't move left because I'm at the first stop. Can I move right? Yeah, I can move right. Right? Can I clean? Yeah, I can clean, right? Or let me try cleaning. Yeah, you see? I run a second time, I can't clean anymore, right? So, I have an agent, right? But I don't really have it's not completely, how should I say, it's not autonomous, right? It's not yet ready to go, right? Because I am driving it, right? It's not doing the job itself, right? I'm sort of moving it, right? It's like on many AI presentations on stage, right? Many of them, it turns out there was like the latest Elon Musk presentation. What was it? It was like maybe a couple months ago. What was it presenting? One of the cars or the bus? Yeah, that's it. Yeah. So there was AI, but also it's partially fake, right? So there was somebody with some remotes, basically, right? So this has a long history, right? So let's do something. So you're going to have something more complex, right? You're going to have a room environment, right? Again, Python is good for this sort of things, right? Easy. You guys all know Python. You know OOP, right? You're going to do some class environment, right? Now, can we make actually so we can move it, right? So we're going to make a living room, really dirty living room, right? Let's make a dirty living room. Okay. Now, let's make another robot class. Now let's see, this is smarter. All right, clean, move. Do I have strategy? Oh, Dima. I don't know what they call Dima. I wonder why did I. All right. Yeah. We finished? Was it really 5:30? That's over. Okay. Yes. But that's very good. So Let's just 1 second. You can always inform me, but don't leave yet. Just 1 second. Let me double check here. Because yeah, it's over, right? But okay. But again, so you can do this at home as well, right? You guys all, but you got the idea, right? You got the idea of this robot, right? But right now, it's missing. It has a it has the movement support, right? But it's not completely autonomous. You have to sort of like it's missing, and maybe try it yourself, right? Sort of like prepare. Maybe I'll do a homework next week for this, right? How would you clean this room? Implement strategy, rules-based strategy. How would you clean this room? So that's something I think.
Just a text-based? Like a text-based? Step-to-step solutions?
Well, that's what I'm saying now, but probably at the homework you'll have to write code, right? Of course.
That's what I'm asking.
Yes, I'm just saying, think about it, how you would do it, right? How you clean a room, a one-dimensional room, right? I mean, it seems, pretty simple, right? But there are a couple, any ideas? Anything comes to mind right now? How would you do this? If you can sense and you can move, what would be an algorithm for this? You can tell where you are, and you can tell whether the room is dirty, whether the style is dirty or not. Well, 2D would be, that's probably going to be homework, 2D based probably, right? But for 1D, what do you do? I mean, you're somewhere. Okay, what do you do? Okay, if it's clean, you do nothing, or what do you do? Okay, but you want to clean everything. Okay, but what? Okay, that's good. But okay, but what if you put in the middle of this strip of land, right? What do you do? Well,
Probably check the tile, which is dirty.
yeah, but okay. So yeah, so that's the question again. So do you only see the next tile, or do you see all tiles, right? Yes. So you can also maybe make some prearrangements. What's the optimal? So there's again difference of strategy which solves the problem and the optimal solving of the problem also, right? Maybe like if you maybe there's some dirt somewhere on the left side, right? And there's no dirt on the right side, you only go to the left side, right? Yeah, something like that. Probably something like that. Of course, yeah. Especially if you're going to do this two-dimensional, right? Probably something like that will be needed, right? Maybe, right? But okay. So what I'm just like getting a feel. You probably next week you have to a simple two-dimensional room cleaning robot, probably something like that. I think maybe some adjustments as a small homework, but not this week. All right, any questions? So simple, right? AI is simple, right? Yeah. Like I said, it's only, of course, in a class setting, it's simple, right? In the real world, it gets the details. The devil is in the details.